At the end of this video, you should be able to determine the optimum solution for degeneracy in the transportation problem using the modified distribution method, which is also called as an UV method. So what is the degeneracy in transportation problem? A degeneracy occurs in a transportation problem when number of occupied cells is less than m plus n minus 1. So what is mean by this occupied cell and what is mean by this m plus n minus 1, that we will see with the help of one example. Degeneracy in a transportation problem can occur at two places. First, while in initial stages, or it can occur when we are reiterating the solution to get the optimum solution. And how to get rid of this degeneracy, that we will see with the help of one example. So this is the statement of our example. There are three factories located at different locations which are supplying products to various three retail agencies. Cost of unit product transportation is given by following matrix. The total transportation cost we need to determine with the help of modified distribution method, which is also called as an UV method. Now many a times it is not specifically mentioned which method is to be used, then you can use whichever method which is more suitable to you, but in this problem they have specifically mentioned to use the UV method. But before we go for UV method, we need to find out the basic feasible solution by any three methods, which are northwest corner method, least cost method, or Vogel's approximation method. So before we go in all those details, let us try to understand this problem. So there are three factories, F1, F2 and F3, which are supplying products to the retail agencies A1, A2 and A3, and this 8 is nothing but the unit transportation cost of transporting one product from F1 factory to A1 distribution or retail agency. So likewise all the other costs have been given. What is the 60, 70 and 80 are the availability at factory F1, F2 and F3. Also the demand at various destinations are given. So this A1 is having a demand of 50, A2 is having the demand of 80 and A3 is having the demand of 80. Now you can see that the total sum of this availability is 210 and also the total sum of this demand is also 210. So in this way it is a balanced transportation problem. If these two figures do not match with each other, then it becomes an unbalanced transportation problem and we have to take a different approach to solve that problem. You can see my other videos to how to solve the unbalanced transportation problem. Now for this problem, we are considering the basic feasible solution by least cost method, and I am directly taking this solution. So we are not going to solve the basic feasible solution with least cost method in this video because of the time constraint. Rather, we will take the directly solution from the other video. So you can watch. If you are not aware of what is this least cost method, you can watch the other video mentioned in the description section. So once the basic feasible solution is available to you, you can proceed for the UV method to verify whether your solution is optimum or not. If it is not optimum, we have to perform certain iterations that we will see next. So what is this 50? So what is this 50? So this solution I got with the help of least cost method, and it says that 50 numbers of goods are to be transported from factory F2 to retail agency A1. Also we need to transport 60 number of goods from F1 to A3 and 20 number of goods from F2 to A3 and 80 number of goods from F3 to A2. So here is a question for you. Whether this solution which we got with the help of least cost method, does it satisfies the row and column constraint? So pause the video and find out the answer. So let us see whether you got the answer correct or not. So what is a row constraint? So whatever allocations you have made in this row should satisfy with the available supply. Right. So 60 is the allocation you have made in this matrix, which is equal to the available goods. So you can see that this constraint has been satisfied. Now this 50 plus 20 gives you a 70, and these two figures are matching. So we can say that this constraint has been satisfied. Now for this third row, this allocation is of 80, which is matching to the availability of 80 or supply of 80. So this row constraint is also satisfied. Looking for the column constraint, so this 50, yes, they are matching 80, and 60 plus 20, 80. So all the constraint related to the row and column are satisfying, and we can move towards the applying the UV method. Before we apply the UV method, we have to check one condition, and the condition is that number of allocations should be equal to m plus n minus 1. So what is m plus n minus 1, and what is number of allocations? Now if you look at the solution that we have got with the help of least cost method, we have 1, 2, 3 and 4 allocations. And what is here? Here all values are 0. So there are 4 occupied cell, so we can say that the number of allocations are 4. And what is the value of this m plus n minus 1? So m represents the number of rows and n represents the number of columns. So there are 3 rows and 3 columns, so this figure gives me a 5, right? And there are number of allocations are 4. So number of allocations are less than m plus n minus 1 value. That is why this problem is called as degenerate problem, and which is happening at the beginning of this problem. So we cannot apply the UV method directly, and we have to, or MODI method directly, and we have to make certain modifications so that we can use the MODI method. And let us see what modifications we need to do. So the rule is that an extremely small quantity, usually denoted by the Greek letter delta, or sometimes also called as an epsilon, is to be introduced in the least cost independent cell. So we have to make the number of occupied cell equal to m plus n minus 1. Now to make that figure, we are short by one cell, so we have to give this delta value or epsilon value, and we have to put this value in any one of the cell. And how to choose that cell? So that cell should be having a least cost, and it should also be an independent cell. So we understand what is meant by least cost, but let us try to understand what is meant by independent cell. Let us see whether the which cell is independent. So for the sake of convenience, I am replacing the occupied values with the help of one dot, so that there will not be much confusion. So I need to find out of this blank cells which is the independent cell having the least value. Okay, so let us try at this point. So I want to verify whether this cell is independent or not. So how do I make sure whether the cell which I have selected is independent or not? So what I will see, I will look in either horizontal direction or in vertical direction, and I will stop to the point where I will find the next allocation. So I am looking in a horizontal direction, and I am stopping at a cell where I find the next allocation. So I got next allocation over here, next dot over here, so I stopped here. Now I will look, either I will go now I cannot go in a horizontal direction anymore. I need to change my direction. So either I can go up or I can go down. So I cannot go up because there are no cells in upward direction. So I will move down till the point I get the next allocation. So I moved to the down direction till I got the further occupied cell. Again I will change my direction and move to the direction in horizontal direction and look for the occupied cell, and I will stop there. So I got this cell as an occupied cell, and again I will change my direction. Now you can see that I am again going to the same cell. So I can say that this particular loop is being generated. So if I start from this cell, okay, I am coming back to the original cell, right? So this particular cell is not an independent cell because it creates the loop. So I will look for the better option. Now among all these cells, it is the only cell which is having the least cost, and which is not occupied. So I will see whether this is an independent cell or some whether it forms the loop. So I will start looking in horizontal direction and I will stop when I will get the first allocation. Now I will I will change my direction, and if I go forward I don't see any further allocation, and I can say that this is the cell which is having an independent quantity. So it is not creating any loop, so I can assign epsilon value over here. So now I can say that this is a very extremely small amount of an allocations which I am making over here, and I am getting m plus n minus 1 occupied cell, and now I can employ the Modi method. So let us apply the Modi method. In order to apply the Modi method, we all know that we have to regenerate this matrix, right? And I will need to add these dual variables. So these are the three dual variables which are corresponding to the three rows. So u1, u2 and u3, and there will be more three dual variables corresponding to the three columns. So v1, v2 and v3. Now we have to consider those cells to calculate the values of this u1, u2, u3 and v1, v2, v3 which are occupied. So there are 1, 2, 3, 4 and 5 occupied cells, and with the help of these cells we are going to calculate the values of u1, u2, u3 and v1, v2, v3. So initially we will assume that our u1 is having value of 0. Also we need to make the use of this formula in order to get the values of these dual variables. So this is u1 vj is equal to cij. What is meant by that? Let us see with the help of one example. So consider this cell which is occupied. Now remember that this formula is applicable only for the cells which are occupied. So what is this u1? So u1 is this quantity. So sorry, ui is nothing but the u1 because we are considering this cell. So and we know that u1 we have considered it to be on 0. So v3, so corresponding v3, right, that we need to calculate. And what is this cij? Cij represents the cost in that matrix. So let us try to understand it one more time. So what is Cij? Cij I have considered it to be 3, and corresponding I is 1 and corresponding j is 3. So I can say that this is the u1 plus v3 is equal to 3, and I know the value of u1, I know the value of Cij which is 3, and with the help of this formula I can find out the value of v3 is equal to 3. Now moving to the next occupied cell. Now we have to select such a occupied cell for which at least one variable is known and other variable is unknown, right? So the next value we can select is the this occupied cell, and for which the formula becomes the corresponding u2 plus v3 is equal to this 9, is equal to this 9. So now I know the value of v3, right, and I know the value of this Cij, and so the corresponding value of u2 becomes 6. Now we have to consider the next occupied cell, and the cell we will selecting will be this cell, because I know already u2 and I can find out the v1. So corresponding to this cell, so this will be the u2 plus v1 is equal to 3, and I know the value of u2 is equal to 6, so value of v1 will be given by -3. Now here is a question for you. With the same procedure, can you calculate the values for two remaining variables, that is u3 and v2? Pause the video and try to find out the answer. So I hope you must have got the answer. So let us verify your answer. So the next thing that we will be looking would be this cell, that is the cell having the Cij value or cost value as 5, and the corresponding variables are u3 and v3, and we know the value of v3, and the corresponding value of u3 becomes 2. And moving toward the last cell, so this is the last cell, right, which is nothing but the u3. So this is u3 plus v2 is equal to this 3, and corresponding value of v2 becomes 1. So now we are ready with the all the values of u1, u2, u3 and v1, v2, v3. Now we are ready to calculate the opportunity cost, as we have all the values of all 12 variables. So what is an opportunity cost? Opportunity cost indicate whether my obtained solution is optimum or not. So let us calculate the opportunity cost. In order to calculate the opportunity cost, we need to use this formula. So Cij minus Ui minus Vj will give me the value of an opportunity cost. We need to calculate the opportunity cost for the all the empty cells. So we don't need to calculate the opportunity cost for the occupied cell. So let us calculate the opportunity cost for the first empty cell. Now here, what is the value of Cij? So Cij is 8, right? And what is I? I is the row, that is first row, and j is the first column, right? And so the corresponding value of Cij is 8 minus ui, so u1 is 0, and vj, so this vj is v1 is minus 3. So 8 minus 0 minus minus 3 will give me the value of an 11. Moving to the next cell, let us calculate the opportunity cost for the second cell. Now here, if you now this is the second cell that we wish to calculate the opportunity cost for. Now here 7 minus 0, 7 minus 0 and minus 1, so it gives me the opportunity cost of an 6. Now let us calculate the opportunity cost for the next cell, and this is the next cell. Before I calculate all these values, I would like to ask you, can you calculate these values of opportunity cost for remaining blank cells? So pause the video and try to find out the answers. I hope that you must have got some answer. I will help you in getting the remaining answer. Now we will calculate the opportunity cost for this cell. So it is given by, this is 8 minus corresponding value of u2 which is minus 6 minus V2 which is given by 1. So my opportunity cost here is 1, and let us calculate it for the last cell, this last empty cell. So it is given by this 11 minus 2 minus 3, and it is equal to 12. So now we are ready with all the opportunity cost. Now, as all the opportunity cost values are positive, we can conclude that obtained solution is the optimum solution. If there were any value which having a negative value of this opportunity cost, we have to take the different approach and we had to make the allocations. So for which you can see my another video. But for this example, as all the values of opportunity cost are positive, we can say that the obtained solution is then optimum. The last step is to calculate the transportation cost. The transportation cost is given by, so how do we calculate transportation cost is number of unit I am transporting over here into the unit transportation cost. So 60 into 3 plus 50 into 3 plus 20 into 9 plus 80 into 3. So if I do all this calculation, it will be a 750. So this is the last answer which we need to be calculated. Thank you.